Greetings to all of you. Myself, Dr. Bhawana Mishra, UGC DS Kothari Postdoctoral Fellow at Central University of Himachal Pradesh. Before starting my presentation, I would like to thank Science Father for selecting me for the International Research Award on Sustainable Agriculture and Food System under the category of Women Research Award. The topic of my presentation is Nano-Phytoremediation, a green approach for environmental cleaning. So before starting the presentation, I would like to tell about what is the soil pollution, remediation and nano-phytoremediation. So soil contamination being one of the major recipients of all toxins, which has a deleterious effect on both human as well as environment health. So these are the causes of soil pollution, which includes mining, industrial waste, and lots of use of agriculture application, plastic waste, household waste, e-waste. So these are results in the soil pollution. Soil contamination is a worldwide concern, therefore effective remediation solutions are required. So there are three different remediation techniques, which include physical, chemical and the biological. Physical methods included soil replacement and capping. Chemical method included soil washing, immobilization, encapsulation, and biological included the bioremediation, phytoremediation. If contamination are reduced, removed using nanoparticle produced by involving higher plants, it is regarded as a nano-phytoremediation. So these are the different methods to remediate the soil pollution. Then moves to the phytoremediation. Phytoremediation is an environment friendly technology with good commercially acceptance and ultimate natural solution of contaminants. It uses the green plants to decontaminate, uptake, stabilize metabolites or detoxify contamination from soil, water and waste. There are several plants which accumulate more amount of metals. They called as a hyperaccumulator plants. These are such as the Elysium, Thalespi, Calendula and various aromatic plants are reported as a hyperaccumulator plants, which include Tagetes, vetiver, chamomile, mentha, rosemary, pomarosa and the pelargonium. This figure shows that why the aromatic plants are the primary interest for the phytoremediation, because there is a minimal or no contamination of heavy metals in their byproducts or final products. And also it benefited because the heavy metals they improve the production of their essential oil, or they improve the quality of essential oil, which has economic value. So these are the families which are reported as a phytoremediation property. And then moves to the nanotechnology application in phytoremediation, that is a nanophytoremediation. Nanotechnology is a technology that is implemented at the nanoscale and can be used for application that benefits society due to the unique physical and chemical features of nanomaterials. Nanomaterials are a viable option for polluted soil remediation due to their large surface area, high number of active surface sites, and the strong adsorption capacity. Nano-phytoremediation is the current methodology for remediation of pollutants, contaminants by using synthesized nanoparticles from plants. In this, the use different strategy enhance the selective uptake of nano-phytoremediation. So this is the how they synthesize. There are two methods, top down and the bottom up. Bottom up approach relies on the nucleating atomic size material into the eventual nanomaterial, and the top up down methods where a bulk material is physically broken down to the make smaller molecules. And the second method is a green synthesis, in under which we used plant extract or the microbial extract to synthesize the nanoparticles, and after synthesizing the nanoparticles, these nanoparticles are characterized via different techniques like FTIR, ADX, XRD, TEM, SEM and the TGA. These nanoparticles has various application. And what are the mechanism of the nanophytoremediation? First of all, on the surface of nanoparticles, these pollutant get adsorbed, and these compound they transported to the above ground tissue through the plant vascular system, and then they transported or translocated to the above ground tissues. So nanomaterial can reduce the phytotoxicity through reducing the available pollutant amount and increasing the plant tolerance to the stress of the high concentration pollutant. So what are the plant metal interaction and nanophytoremediation techniques? There are several techniques like nanophytostabilization, nanoimmobilization, nanostimulation, nanophytostimulation, phytovolatilization, rhizoimmobilization. So nanophytoremediation facilitates the degradation of resistant complex organic compounds into the simpler compound by the joint activity of microbes and plants enhanced by the nanocapsulated enzyme. So these are the various nanophytoremediation techniques. Then what are the factors affecting the nanophytoremediation of contaminants? Like there are several factors like contaminants, like which molecules, what are the molecular weight, what are the types of bonds present in that contaminants, what are the moieties, mobilities, solubilities, hydrophobicity. And for the plants there are several factors like what age of plant, what type of plant, like herb, shrub, trees, what is the rooting system, it's a weak rooting system or a strong rooting system, fast growing plant, low growing plant, have a higher yield or lower biomass yield. And like that there is various environmental factor, what is the temperature, pH, humidity, moisture content, toxic contaminant and the oxygen content, light. And for the nanoparticle there are factors like structure of the nanoparticle, either it is cylindrical, cubic structure, crystal structure, size, like it is a 1 nanometer, 10 nanometer, 100 nanometer. And there is a composition, concentration, physical characteristic, chemical properties and the surface activities. There are several factors of nanoparticle, contaminants, plants and environment which affect the nanophytoremediation activity of the mechanism. Then what are the ideal plant characteristic? First, it has a capability to accumulate more amount of metal in their tissues, that is a hyperaccumulation. It should be fast growing plant, produces large biomass, has ability to tolerate more and accumulate more metal content. It has a well developed root system and easy to harvest, non consumable by human and animal, and susceptible to genetic manipulation. Then moves to the selection of nanomaterial used for phytoremediation. What are the characteristics of nanomaterial? Characteristic of the nanomaterial. So first of all, capability to bind contaminants and increase bioavailability of plant. Second, nanoparticles should be non-toxic to the plant. Third, ability to enhance the plant growth hormone. Fourth, increase germination rate, seedling growth, root shoot elongation, plant height and biomass. And then enhance phytoremediation process and the significantly increase phytozyme production in plants. So what are the role of nanomaterial in phytoremediation? First, the nanomaterial used may be implicated in the interaction between contamination and plant, influencing the final remediation efficiently indirectly. And second is the nanomaterial have the potential to increase phytoremediation by directly interacting with contaminants and the plants. So these are the three main components of the nanomaterial assisted phytoremediation system, that is a plant, contaminants and the nanomaterial. These are the some example of nano-phytoremediations. Like iron nanoparticle are the most frequently used for the remediation process. Some researchers investigated that nanomaterial decontaminate the organic pollutant like PCB, PH, PPCPs, and the nanoscale zero valent has been used to reduce the environmental contaminants. Nano-phytoremediation for the degradation and removal of TNT is more effective than the either nano-remediation or the phytoremediation techniques. So these are the application of nano-phytoremediation, that is the heavy metals and other metal remediation, recalcitrant organic pollutant remediation, radionucleosides remediation, chlorinated and biphenyl remediation, and fertilizer and pesticide remediation. So what are the challenges of phytoremediation? So nanomaterial assisted phytoremediation studies are very scarce, and prospective studies are also needed to determine the actual effects of nanomaterial in the phytoremediation process and changes in soil fertility status. Sustainable nano-phytoremediation is primarily dependent on the meteorology circumstances, hence environmentally stable nanomaterial. So these are the some of my publication related to the nano-phytoremediation techniques. Thank you so much to all of you. Thank you.